Welcome back everyone. Today is the last lecture of polynomials. In this lecture we will mainly deal with the division algorithm for polynomials. So let us start. Polynomials class 10. So the division algorithm. So division algorithm of polynomials. Now before starting this thing, you have to remember a very simple thing, that is, it is the Euclid's division lemma, or the simplified format of which is actually dividend equals to divisor into quotient plus remainder. That is, for example, we are dividing 25 by 4, so 4 6 are 24, remainder is 1. So here 4 is the divisor, 25 dividend, 6 is the quotient, and 1 here, it is the remainder. So sorry for the sound, actually a bike is going, by the way, motorcycle. Okay, it has gone, sorry for the inconvenience. So here this thing, right, that divisor dividend equals to divisor into quotient plus remainder. Now what happens is that if all these things were represented in terms of algebraic, when all these things are represented in terms of algebraic polynomials or expressions, then it becomes the division algorithm for polynomials. So what I mean to say by this is, for example, we are having an algebraic expression. For example, let us have an algebraic expression like x square minus 3x plus 9. This is the algebraic expression or a polynomial. Now we divide it by x minus 4. While in this process we get some quotient here and we also get some remainder. And here the remainder and quotient, as these are, as the divisor and dividend are of the format of algebraic polynomials, so these are also of the format of algebraic polynomials. So basically this is nothing new. Basically the Euclid's division lemma, which you have learned in the real numbers chapter, it was for only numbers. That is, when we learned that thing, divisor dividend equals to divisor into quotient plus remainder, we learned that for numbers. For that is 25 we divided by 4, 4 6 are 24 and 1. So here we have learned that 25 equals 4 into 6 plus 1. Now we are actually doing the same thing in case of algebraic expressions, and at that time this is actually being termed as the division theorem for algebraic polynomials. Now to write it in a formal way, let me write, let us take 4 algebraic polynomials, that is p of x, g of x, q of x, and finally r of x, where p of x, it is the dividend, g of x, it is the divisor, q of x, it is the quotient, and r of x, it is the remainder. So in this case we can write dividend equals to divisor into quotient plus remainder. So p of x equals g of x into q of x plus r of x. This is the thing. So you can understand this is nothing new, only just a little bit modification of what we have already learned. So before proceeding any further, we must review a few things. That is, in the previous lectures we have learned that if k is a 0 of the polynomial, k is a 0 of the polynomial p of x, then x minus k is a factor of a polynomial. You must remember this thing. If you want to know this thing in great detail, then please refer my previous videos. There I have explained this thing in great detail. So what I want to tell you now is that let us in a particular case, let p of x, that is the dividend, equals to the divisor, that is g of x, into the quotient q of x, and there is no remainder term. That is, the polynomial is fully divisible by its factor. There is no remainder. In that case, for example, if we know a particular factor of the polynomial, we can know the other factors too. That is, for example, let us take a polynomial p of x. And we know one of its zeros is k. So when we know that one of its zeros is k, then we can also say that one of its factors is x minus k. So x minus k is a factor. Now if we divide p of x by x minus k, then the quotient here will be the product of the other factors. I hope this is clear. I am telling this again. We know one of the factors of the whole polynomial. So now if we divide the polynomial by one of the factors, then the quotient which we will get will actually be the product of the other factors. That is, let us take an example. For example, you have 8. You have 8 and you know 2 is a factor of 8. So if you divide 8 by 2, then you will get 4 and no remainder. So you know that you already know 2 is a factor of 8. So if you divide 8 by 2, then you are getting 4, where 4 is actually product of the other factors, that is 2 into 2. We know actually 8 equals to 2 cube. So we only know a single factor, that is we only know the 2. So if we divide 8 by 2, then the quotient we are getting is actually the product of the remaining factors. That is what is being said here. This is important and you will need this thing. So actually in class 10 NCERT, this is all about the division algorithm. Based on the last thing which I said, there may be some questions framed. I am taking a question for example, and after this you will be able to solve the other questions in NCERT. So the question is, find all the zeros of the polynomial 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2 if two of the zeros are root 2 and negative root 2. Now this is a good question. Before going to the solutions, let me remind you something. Now this is a 4-degree polynomial. Therefore it will have at most 4 zeros. You know this thing. I have already explained these things in my previous lectures. If you don't know, please see them. So 4 zeros we have. Of them, only 2 zeros are given. that is the two given zeros are root 2 and negative root 2. Now from here we can say if the two given zeros are root 2 and negative root 2, then x minus root 2 then x minus root 2 and x plus root 2 are two factors. Now from this we can say that if these two are two factors, then the multiplication of them will also be a factor. That is x minus root 2 into x plus root 2, which is equals to x square minus 2, is a factor. Now you can understand this thing. For example, 8. Let's not take 8. For example, 12. Okay. So for example, 12 has 3 factors. For example, 12 has total 4 factors. Let it be 2 into 2 into 3. For example, 12 has 3 factors. Now we know only 2 of them. For example, we know this 2 and we know this 3. So if we know that 2 and 3 are factors, then 3 into 2, which is 6, is also a factor of 12. This is the thing which I am trying to explain you here, that if we know 2 factors, then the multiplication of them is also a factor of the polynomial. Now the last concept which I told you will come into play. So we know that what is the polynomial given? The polynomial given is 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2. Now we know that this has at most 4 zeros, and combining its 2 zeros which were given, we have found that x square minus 2 is a factor. Now if we divide the whole thing by x minus 2, then we will get the product of the other factors which I told you earlier. So let us do that. So let us divide. So 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2. We divide this thing by x square minus 2. So dividing, it goes 2 times. So 2x square times. So 2x to the power 4, and this is minus 2x square, right? Minus 4x square, right? Minus 4x square. So doing this thing, this gets cancelled. So minus 3x cube. This will be plus when I subtract it. So plus x square plus 6x minus 2. Now to make this thing again divide, we have to multiply by minus 3x. So it becomes minus 3x cube plus 6x. So plus 6x. Now these two gets cancelled. So this comes out to be x square minus 2. So plus 1, that is x square minus 2, and finally we get 0. So the quotient here is 2x square minus 3x plus 1. So therefore product of the remaining factors, the product of the remaining factors is the quotient we got here. The quotient is 2x square minus 3x plus 1. So is 2x square minus 3x plus 1. Now as we are telling that the product of the remaining factor is 2x square minus 3x plus 1. Now if we are able to factorize 2x square minus 3x plus 1, then we will be able to get the actual factors. So factorizing 2x square minus 3x plus 1 equals to 2x square minus 2x minus x plus 1. So it is 2x x minus 1 minus 1 x minus 1. So equals to 2x minus 1 into x minus 1. So finally we have got all the factors of the polynomial. Initially it was given, just wait a minute. So initially it was given, initially two zeros were plus minus root 2, therefore two factors were x minus root 2 and x plus root 2, x plus root 2, and with the help of them we finally evaluated the other two factors. Other two factors are 2x minus 1 and x minus 1. Now we are actually asked to find all the zeros. So now we have got the four factors, x minus root 2, x plus root 2. These were already given, that root 2 and minus root 2 were the two zeros. Now from the rest two factors we can evaluate the remaining zeros. That is, to evaluate the remaining zeros, what we have to do? We have to is that we have to just equate them to 0. So 2x minus 1 equals to 0, that is x equals to 1 by 2, and from this one we get x minus 1 equals to 0 or x equals 1. So the other two zeros are x equals to 1 and x equals to half. So finally we can conclude that what we can conclude is that these electronic gadgets sometimes lags a bit. So finally the zeros are root 2 minus root 2, which were already given, and what we evaluated is half and 1. So I hope this is clear. After this you can solve, I think, the rest of the examples of NCERT. So I hope this is clear for every one of you. And one thing which I would like to just add, because in the previous lecture this is not actually included in your NCERT syllabus, but I mean it is in the book, but it will not come in your exam. That is, I forgot to cover this in the last lecture. That is the relation between the roots and coefficients of a cubic polynomial. So for that I will just give you the formula here. From these questions will not be there for your board exam. So if a polynomial is of the format ax cube plus bx square plus cx plus d and its zeros are alpha, beta and gamma, then the relation between the roots and the coefficients is alpha plus beta plus gamma equals to minus b by a, alpha beta plus beta gamma plus gamma alpha equals to c by a, and alpha beta gamma equals to minus d by a. Now this thing I will not cover because there is no need to cover this thing. What you can do is you can actually check your NCERT. In NCERT, there is an example on this where you have to just evaluate the values based on this formula. So check the example, and there it is also written that it is not in your syllabus, so just check it once. So finally it is over, and we have come to the end of the polynomials. So I hope what I want to teach today, the division algorithm, is clear to you, and I hope you have understood the concepts. So thanks for watching. The next series will be of pair of linear equations, so stay tuned. I will be back soon. Thank you.